Hey guys, welcome back to Bison Maths. My name is Mr. Bison and this is the third part in the series of videos of everything you need to memorise for your A-level maths. This part is going to be on statistics. If you haven't checked out part 1 on pure and part 2 on mechanics, then go to my channel homepage and have a look at them. If you're new to my channel, have a look at some of the other things I've got there. I've got hundreds of videos of my real life lessons with students in my school, and they should be really useful for your revision or for learning any topics that you may not have understood so well. Okay, so this third video is about statistics, and I've found from my experience, students either tend to get really high marks or really low marks. The students who get really high marks aren't naturally better at statistics. I think that they have just memorized a lot of content and realized that statistics is quite formulaic in what they expect you to do. The people who get low marks, I don't think have spent enough time with the content, and I don't think they really know all of the little tricks that I'm about to show you. So without further ado, let's get on with the video and I'll show you everything you need to memorize for statistics. Okay, so as you can see, there's quite a lot of stuff that you need to memorize for statistics, a little bit more than mechanics. And we're going to get started by having a look at data collection. So this is an area people often tend to leave off a bit, but there's lots of valuable marks that we can get here. So let's get started straight away. So first of all, some keywords here. When you see the word census, if they ask what that means, a census is something which measures every member of a population. And what I've written here, these little plus and minuses, they are going to refer to advantages and disadvantages. So the advantage of this is that this should be an accurate result. And the disadvantage of this is that it's probably going to be very expensive or time consuming, and sometimes the testing may destroy the units that you're talking about. So I think there's an example in the textbook where they talk about testing all of the avocados to see how ripe they are. That would destroy the avocado, so it's not a very good thing to do to all of them. The sampling units are the individuals of the population. The things that you might want to sample. They don't have to be people, they can be avocados. The sampling frame is a list of sampling units. And so a sampling frame might be something like a list of all the students in the school, or it might be a list of all the residents in a particular area. So what types of samplings have we got? Well, for random sampling, there are 3 types. We have simple random sampling, and the question mark here is to say, what is it? Well, it is to give everything the same chance of being selected. And how do we do this? Well, for a random sample, we can either use a random number, and we do that usually with a calculator to get a random number generator, or we can do something which is called lottery sampling. Lottery sampling is where you put all of the written names of people or whatever it might be in a hat or a bowl, and you just pick them out randomly. A bit like in the Hunger Games, where they pick out the tributes to go to the Hunger Games. And what's the advantage of this? Well, the advantage is that it's bias-free because it's completely random, but the disadvantage is that you need to have a sampling frame. In other words, you need to know all of the possible things that you might be picking from, and that's not always going to be available. Systematic sampling kind of sounds a bit like what it's talking about. It's following a particular system. So what you do for this is you would take every kth unit. So it might be every 3rd unit, every 100th unit. And K is going to be found by taking the size of the population and dividing it by the size of the sample that you're looking for. But what you also need to remember is that to get started, you need to pick a random number, and that random number needs to be between 1 and K. And that is for your starting point. So maybe your first starting point might be number 3, and then you're going to go every 5, so you'll go 3, 8, 13, etc. Now, the advantage of this is that it's really quick to use. But a disadvantage, again, is that you need to have a sampling frame. I'm trying to keep as many of the advantages or disadvantages kind of similar to each other so that you can use them for several types of sampling. Then we've got stratified sampling, and this is where the sample represents the group or the groups, which are called the strata of a population. So the word strata actually means group. And the way that you do this is you take your sample size and you divide it by the population size to get the proportion that you want, and you multiply this by the strata for each strata, the size of the strata, sorry, for each strata, to find out how many people you need in that group. And then within that, you pick them randomly using a random technique. So that could be lottery sampling, or it could be using random numbers as well. So the reason this is an advantage is because it reflects the population. So this is maybe why you'd want to do something for like not exit polls, for political polling. You want it to represent the population, but the disadvantage is that your population must be classified in strata. And that's not always going to be obvious. It might not be clear like what groups you particularly want to put a population into. So then we move on to non-random sampling, and there's two types of this we need to know about. The first one is called quota sampling, and this one is a bit like stratified sampling, but instead of picking them randomly, the strata are filled by an interviewer or a researcher. So they get filled up in a different kind of way. Now, the advantage of this is that you don't actually need to have a sampling frame. So you might put like an advert out to say, we are looking for this type of person. So you don't actually need to know the list of people. You can get them coming to you in a different kind of way. But the disadvantage of this is that it's actually not being random anymore. And so there's some potential bias that there might be. Then we're going to look at opportunity sampling. This is the one that's like you're outside a supermarket and you pick 5 people to try a product. It's just taking advantage of what you could be, of what's in front of you. So this time the quota is filled by those available at the time. Like I was just saying, like at a supermarket or something. And the advantage of this is it's really easy to do. It's also pretty cheap. You could probably just do this like in your school, just go up to people and ask them some things. But the disadvantage is that it's unlikely to be representative. You may end up getting a particular type of person if you're stood at a particular type of supermarket, for example. And I've written here, note, there are other advantages and disadvantages. I've just picked one of each to try and minimize the amount of things that you need to memorize. So we need to know about the last part, different types of data. If something is qualitative, that means that it's going to be like a non-numerical type of data. So usually like words, a color, something like that. And quantitative is then going to be numerical data, and numerical data is either discrete, meaning it can take fixed values, or continuous, meaning it can take any value in a particular range that we've got there. Now, I've tried to condense the large data set as much as possible, but there's always going to be more things you need to know about this. So if you are interested, I have got a video about the large data set, and I can link that in the description too. So the first thing that you need to be able to do is name all of the stations, the weather stations in the UK. So here's my map of the UK. Now I start at the bottom and they go in alphabetical order. So this one at the bottom, which is on the coast, is Camborne. They don't quite go in alphabetical order, I need to take that back. These two down here are Heathrow and Herne, but everyone knows that Heathrow is the one that's in London. And this one down here is Herne. Then, if you can remember the next ones, we have Leeming and we have Leuchars. And again, you can see that that's going in alphabetical order as we go from here upwards. The only difference is that these two have switched around. Okay, so let's talk a little bit more about the UK stations. I've drawn some symbols to try and help us think what these might mean. Well, an area of the UK station that is windier and rainier, that is going to be the areas which are coastal. So any of the coastal stations are going to be windier and rainier. Then I've got another bit down here, is I've got some area where there is more sunshine and it's warmer and there's also more sunshine in the day. That's going to be generally the weather stations that are in the south. They tend to be warmer and they tend to have more sunlight as well. So when is this large data set being recorded for? Well, it's for just 6 months between May and October in 1987 and 2015. So you need to make sure that you know that. So it's a bit of a disadvantage to only have 6 months. You're never going to get a whole picture of the year here. Now, there are 3 international stations, and I've done some symbols to try and help us think about what makes them unique. So this first one, I've got that the summer and the winter are switched around. Well, hopefully we know that the ones where summer and winter have been switched around, this is going to be Perth, which is in Australia, because it's in the southern hemisphere, so it actually has different seasons to us. When we have summer, they have winter, and vice versa. Perth is also very hot in the summer, so that's something else to note. Now, the second place that I've got here, I've said that it has really hot and it's also really rainy in the summer, and in the winter it gets very, very cold. So it's more extreme, more seasonal, and this is Beijing, which is in China. Now we know what the last one should be, but I just wanted to talk through what I've got written here. Generally, this place is very, very warm, and it's also prone to having hurricanes. I know this looks like a tornado, but I think it makes us think of something being windy. And in Jacksonville, which is in which is in Florida in the US, there were 2 hurricanes. There was a hurricane in October 87 and a hurricane in October 15. So this is Jacksonville, which is in Florida, USA. And when I think of Florida and Miami, I think of places that are warm in the summer, and it generally stays quite warm throughout the year. So a few things you need to know about the kinds of data that you've got here. First of all, when you're measuring the rainfall, this letter TR comes up in the data. And what this actually means is it means trace. And it means less than 0.05 millimeters of rain. And you treat this as 0 in any calculations. And if it ever says NA, it means that the reading is not available. And this is going to be a problem if you're taking a sample, so you can't use it in a sample. Okay, and then cloud cover. You need to know about cloud cover, that cloud cover is measured in octars, and these are discrete values, and these are integers from 0 to 8. So there's actually 9 different options, and it's just measuring how many eighths of the sky is covered in clouds. And then last of all, we're going to talk about the maximum gust. This is just talking about the strongest speed that the wind will get to on a particular day. This is measured in knots, and 1 knot is equivalent to 1.15 miles per hour. And you also might want to note that there was the Great Storm in the UK, and that was on October the 15th and 16th, and that was in 87. So you might get some data about October 87. It's worth remembering that there was a Great Storm in the UK at that time. Okay, so we're going to move on to a next part, which is about the location. So location means about where the data is, what size the numbers are. And I've written here, know your calculator. I'm not going to be including this in this video, but you need to know how to find all of these things using your calculator. So to get started, you need to know that this x bar, which means the mean, is the sum of the x values divided by n. And if this is in a grouped table, it's going to be the sum of fx divided by the sum of f, because the sum of the frequencies is just how many pieces of data that there actually are. Now, if you have listed data here, to try and find out the position of the lower quartile, which is Q1, you take the number of pieces of data and divide it by 4. The median, you divide it by 2, and the upper quartile is 3/4 of the way along, so you have 3n over 4. When you do that, if you get a decimal, what you do is you round up, and then you find that position, and that will correspond to Q1, Q2, or Q3. If it's whole though, you find the midpoint with the next number. This is only for listed data. If you have grouped data, to find the position of Q1, you still do n divided by 4, you do n divided by 2, and 3n divided by 4. If it's percentiles and you wanted to find the 57th percentile, so you'd call that P57, you do 0.57 multiplied by n, you're going 57% of the way along. And deciles, these are 10% chunks, so you might say that D3, that's actually saying that that's like going 30 percentiles along, which is just going to be 0.3 multiplied by n. So that's how you find the positions. You don't do any rounding or any of the stuff that I've mentioned up here for these. Instead, you use linear interpolation. And so I'm actually thinking the best way to do this is actually to do an example of linear interpolation. So what I've got here is I've got some weights which have been measured to the nearest kilogram, and then I've got something called true class limits. Now, true class limits means you need to take them from these rounded values in the first column and actually say what they are representing. So this first one is actually going to be representing from 9.5 all the way up to 12.5. We can't have any gaps. This one will then be going from 12.5 to 15.5, and then the last one that we've got here will be going from 15.5 all the way up to 18.5. And then the frequencies, to find the median, we're going to do the cumulative frequencies. So we would have 5, add on the 8 to get 13, add on the 7 to get 20. So the second quartile, which is the median, you would divide it by 2, and it's going to be the 10th term that we've got here. So to do linear interpolation, we can clearly see that that's going to be lying in this group that we have here. because it's going to take us from the 5th to the 13th term. So at the bottom, you're going to write that it starts at the 5th and it goes up to the 13th, and we are looking for the 10th term that we've got here. I've put it roughly in the right place. That group goes from 12.5 and it goes up to 15.5, and we are looking for the median, which is here. Well, to find that median, we need to keep the proportions the same. So I want to go from 12.5 that I've got here, and I want to add on the same fraction along the way that I've got. So on the top, the fraction is between here and here, this is a gap of 5, and between here and here, this is a gap of 8. So I want to go 5/8 of the way along that bottom gap. And you can see that the whole length of it is 3. So I want to go 5/8 of the way along from 12.5. I want to go 5/8 of 3 along from 12.5. So I'm going to just quickly on my calculator do 12.5 plus 5/8 of 3, which is 14.375. So the median is 14.375 kilograms. It's all about keeping the proportions the same there. Okay, we're going to now move on to have a look at spread. So again, I've said here, you really need to know what your calculator is. I've put a little F with a heart here. This comes in the formula book. The heart says you should try and learn this off by heart. So the interquartile range is just Q3 minus Q1. And I've put here a plus. The advantage of this is that it ignores extremes. The interpercentile range, they might ask for the 10th to 90th interpercentile range. This is just going to be P90 minus P10. They can give you different percentages for that. Then we're moving on to variance. So the variance is found by doing the mean of the squares minus the square of the means. And that's what I've written here. I've got MS, MS, M. So I'm just going to write that down. It is the mean of the squares minus the square of the means. So I'm now going to do it for grouped data. This is going to be the sum of f of x squared divided by the sum of f minus the mean of the squares. So this first thing here is the mean of the squares, and this is the square of the mean. And I've written here as a note that the sum of f of x squared is not the sum of f of x squared. You square the x values before multiplying it by the frequency, not squaring it afterwards. Okay, we're going to move on to coding. Coding. So if I have coded my data so that y is equal to ax plus b, well, the y bar would be the x bar multiplied by a plus b. So it's affected by both of those values. But the standard deviation of y is just going to be a multiplied by the standard deviation of x. It's not actually going to be related at all to the b part of it. It doesn't matter about it adding or subtracting. It's also probably just worth noting here, the standard deviation is obviously just going to be the square root of this expression, because that's sigma squared. So it would just be sigma for standard deviation. Okay, we're now going to have a look at representation, so a few different types of diagrams that we have here. And this one, I'm going to start off with cumulative frequency and then move on to box plots. So if you have a cumulative frequency diagram, you can use it to draw a box plot. So the halfway point is going to be the median, and you can see that when I draw this line down here, it's corresponding to the median. Then halfway between the start and Q2 is Q1, and you can see that's corresponding to Q1 on my box plot. You can then draw 3/4 of the way for Q3, and that's corresponding to that part of the box. And then the top value is going to correspond to that extreme value. Notice how this is going to correspond to the minimum extreme value as well. So for the box plot that we've got here, this represents the minimum. This one represents Q1, Q2, Q3. This is the maximum, and this is what we call an outlier. The length of this box here is the interquartile range. Now the outlier boundaries, the way you would find these is you might do Q1 minus 1.5 times the interquartile range, and the other way you might find it is you do Q3 plus 1.5 times the interquartile range. That's a standard way of finding out where the outliers might be, but they would usually tell you that in the question. So it might not always be 1.5, but it's always going to be something above or below the upper and lower quartiles. Okay, so we're going to now have a think about histograms that we've got here. For histograms, it should be used just for continuous data. If they say, why should you use a histogram? It might be because the data is continuous. You'll notice there are no gaps in the diagram. If you need to calculate the frequency density, you do the frequency and you divide it by the class width. Now, the area is not equal to the frequency like it was in GCSE, but the area is equal to the frequency multiplied by some constant k, which you will probably need to use during the question. If you ever get asked to make a comparison between two diagrams, you need to compare two things. You need to compare one measure of location, and you need to compare one measure of spread, and usually you should put some of these into context. If it's asking about the time that someone took to run a race, you probably want to talk about that time rather than just the explicit values of location and spread. Okay, so we're going to move on to the next part, which is about regression and correlation. Again, I've said know your calculator. You need to know how to be able to find the product moment correlation coefficient, PMCC, on your calculator. Now, R can vary between -1 and 1, and it measures the strength and positivity or negativity of the correlation. So that's why it can only be between 1 and -1. A regression line is basically just a posh word for the line of best fit. It will usually be in the form of y equals a plus bx. And in this particular context then, a is going to be the value of y when x equals 0. So they might ask you to interpret something. And b is how much y changes with x. How much y changes with x. In particular, how much it changes when x increases by 1. Interpolation is when you estimate inside the data range. So it's estimating inside the data range. And I've put a tick next to that because interpolation is usually more reliable. Extrapolation has a cross because it is not a reliable thing to do. They love to ask these kinds of questions and say, why has someone done this wrong? And it's because usually they have gone outside the data range, which means they have been extrapolating. You may have some exponential or non-linear models where you want the line of best fit to be curved or a different kind of shape. If you have something like y equals ax plus b, ab to the power of x, or y equals ax to the n, what you need to do here is take logs. Now I'm going to skip a step. You can take natural logs or you can take logs of base 10, whatever you want to do. So you should get ln y equals ln a plus x ln b. Again, you can use logs instead of ln. And this one here, you would get ln y equals ln a plus n ln x. And then you can go ahead and do the same things as before. So we're going to have a look at probability and Venn diagrams in particular. So here I want to do an example of shading in A dash U B. And this is the union of the complement of A and B. The complement of A actually just means not A. So for unions, what you do is you actually shade all of both of the regions that have been suggested. So I'm going to start off by shading not A. Well, not A is going to be everything that is outside of A. And you also need to shade all of B, so you've got this bit that we've got here. So that shading is not A or B. Intersections is a little bit different. All you need to do for the intersections, which is this N shape, is you just shade the overlap. So you need to think about the the one place where it is not A and it's B. Well, not A is everything outside of A, and B is the thing that's here. So the only place where they are overlapping is that section. Okay. Tree diagrams now. Tree diagrams, you probably know this from GCSE. As you go along the tree diagram, you multiply. There's a little bit of new notation though. This bit that we've got at the end here, this is going to be B, given that A has already been picked. This is not B, given that A has been picked. This is B, given that A has not been picked. And this is not B, given that A has not been picked. You can use all your same skills from GCSE for tree diagrams. Now I'm going to talk about some other things to do with probability. So if you have something about mutual exclusivity, if A and B are mutually exclusive, the probability of A and B is going to be 0 because they can't happen at the same time. The probability of A or B is just going to be the same as the probability of A plus the probability of B. And as a Venn diagram, they do not overlap each other because they have no overlap. Independence is something they love to ask about. Now, these are in the formula book. I haven't put a heart by them because you may just like to have them to refer to in the exam. But the probability of A and B, if they are independent, will just be the same as the probability of A multiplied by the probability of B. And the probability of A given B is just going to be the same as the probability of A. A mistake that lots of my students make is they think that you can tell from a diagram, a Venn diagram, if they are independent, but you can't. So these are the tests that you can use for independence. Conditional probability is in the formula book, but it's not in this form, and I prefer this form about how to do this. So conditional probability, the probability of B given A is the same as the probability of A and B divided by the probability of A. And you'll notice that this second letter here is the thing that we are dividing by. If you're looking at a Venn diagram for this, just reduce the whole space to the thing that is given that. So here I've reduced it by just looking in and zooming in on this area, and then you just deal with all the probabilities and numbers that you've got in that space. And again, if you're not sure what I mean here, I've got a few videos that might help you. Last of all, the addition law is in the formula book, so you may not want to memorize this, but this is just the probability of A plus the probability of B minus the probability of A and B. Okay, we've got 2 more columns to go. Let's see what we've got next. We are going to be looking at a very, very tiny bit, which is the discrete uniform distribution. And I've seen this pop up, and it's easy marks. The discrete uniform distribution is where the probabilities of all outcomes are equal. So for example, going back to the large data set here, if the discrete random variable x is cloud cover, which is measured in octars, then your uniform distribution will look like this. X can take the integer values between 0 and 8. We talked about that earlier on. So there's 9 different options, which means that the probability of all of them is going to be a 9th. So it's discrete because it can take all of the values between 1 and 8, and it's uniform because they all have the same probability. That's actually one of the questions that students performed the worst on, and I've got a video about the top 5 hardest questions, which I will link for you to have a look at. Okay, now we're going to have a look at the binomial distribution. The binomial distribution, so we would say that x is distributed binomially, and it has a number of trials n and probability p. This next part is in the formula book, but it's worth trying to know this one as well. So the probability that x is equal to r is the binomial coefficient n choose r, the probability to the power of r, and then 1 minus the probability to the power of n minus r. This one looks more confusing, but when you do it with an example, it all just tends to make sense. So when can you use a binomial distribution? Again, this is easy marks if you can just memorize this. So I've put FFIT to help us try and remember this. So the first one is that there are a fixed number of trials, n. The second thing is that there is a fixed probability of success. And that probability is P. The I stands for that the trials must be independent. And the last thing, the T stands for 2 outcomes in this particular experiment or whatever might be going on, and those 2 outcomes are just going to be success or failure. Now with the cumulative probabilities, the probability that x is less than 5, it couldn't be equal to 5, that means it could be 1, 2, 3 or 4. So actually we would find out using our calculator the probability that x is less than or equal to 4, the 5 isn't included. And your calculators can only do it with the less than or equal to sign. I've put know your calculator, so you better make sure how to do this. Now if you wanted to find the probability that x is greater than 3, well we're asking really for 4, 5, 6, 7, etc. So that means we're going to do 1 minus the probability of x being less than or equal to 3. We're subtracting all of the ones that are 3 or less. And we want between 6 and 10. Well, 6 isn't included. We just have 7, 8, 9, and 10. This looks like you would start off with all of the values less than 10, and you would remove all of the values where x is less than or equal to 6 to get left with that range. And I like writing the numbers to help me visualize what's going on. If you're going to be doing inverse probabilities, use the tables. They are better than the calculator. Again, you can have a look at my videos about how to do that. So we're coming up to the normal distribution. The normal distribution is for continuous variables, and it's a continuous random variable y. I will use the letter x for the binomial, and I'll use the letter y for the normal. So y is distributed normally with a mean of mu, and the variance is sigma squared. This is something that is mentioned in the specification and barely mentioned anywhere else. So there is a point of inflection, meaning that it changes, it goes from convex to concave at 2 points, at mu minus sigma and mu plus sigma. So these are the 2 points of inflection. You also need to know about how much data there is within particular standard deviations of the mean. So 68% of the data will be within 1 standard deviation of the mean. 95% of the data will be within 2 standard deviations, and 99.7% will be within 3 standard deviations of mu. Finding probabilities and the inverse normal, this is like how you would find this kind of thing or find A in this kind of situation. You just need to know how to use your calculator to be able to do this. The standard normal distribution, we use the letter Z. We would say that Z is normally distributed with a mean of 0 and a variance of 1 squared. And to do that coding, to make something become the standard deviation, you take the Y value, you subtract the mean, and you divide by the standard deviation. If you have missing mu, sigma, or both of them in a particular distribution, you use the coding that you have. If you have just one of them, it will be an equation. If you have both of them missing, it will be a simultaneous equation. Then what you can do is also approximate binomial distributions as normal distributions. You can only do this if n is large. How large isn't clear usually, could be 30, 40, 100, but usually they would ask if it's a large value, and you can do it if p is approximately 0.5. 0.4, 0.6 is probably okay, 0.2, 0.8 is probably not going to be okay. And for this distribution, the mean is going to be np, so the number and multiplied by the probability, and sigma is going to be the square root of np 1 minus p. Continuity corrections. If you are approximating binomial as normal, you're going from something that's discrete to something that is continuous, and so you need to change the particular probabilities you're looking at. If you're saying that the probability that x is greater than 5, that is going to be changed to the probability that y is greater than 4.5. You could have all the equal to sign, but it's not going to change the outcome for the probability. And if it was between 3 and 11, well, you would say that it's going to instead be between 2.5 and 11.5. So you basically add on a half at either end to try and sort of expand out that range. Okay, so we're moving on to the last section. I've put all of the hypothesis testing together here. So for hypothesis testing, we need to know some of these definitions. First of all, the null hypothesis we write as H0, and this is what we assume to be true. Even if you can't do the whole question, get yourself some free marks by writing out your null and alternative hypotheses. So the alternative hypothesis is H1, and it's what would be true if H0 is wrong. Then we have the significance level. The significance level, we usually use the letter alpha, and this is the given threshold of likeliness. This usually makes more sense when you're actually doing a question. So a one-tailed test. You do a one-tailed test when the alternative hypothesis is something like the probability is greater than k or the probability is less than k. A two-tailed test is when your alternative hypothesis is that the probability is not equal to k. And what you do in this situation is you halve the value of the significance level for each end. So you just need to make sure you know the difference. If it's a two-tailed test, you halve the significance level. Okay, so correlation testing that we've got here. This goes back to your correlation and regression bit. Your null hypothesis is going to be that the correlation is 0. We assume that it has no correlation. The alternative hypothesis will be clearer from the question. It will either be that it has positive correlation or it will be that it has negative correlation. These two are both going to be one-tailed, or it will be that there is some kind of correlation. It doesn't say positive or negative. So this one is going to be your two-tailed test. What you do here is you compare your value of R with the table. If your R is more extreme then you reject H0. And you need to give that some kind of context and say, therefore there is some kind of correlation and there is a relationship between these variables, and you actually name what the variables are. If your R is less extreme than the value in the table, then there is no evidence to reject H0. That doesn't mean that H0 is definitely true, it just means that there's no evidence to reject it. So with binomial testing that we've got here, the test statistic, this is the number of successes observed. And the null hypothesis is that the probability is equal to some value k, and this is usually going to be given in the context of the question. The alternative hypothesis for a one-tailed test, it will either be that the probability is greater than k or that the probability is less than k. So these are my one-tailed bits, or it might be that the probability is not equal to k, which would mean that it becomes a two-tailed test and you're going to have to halve that significance level. What you then do for the third step is you assume that H0 is true, i.e. that x is binomially distributed with n and k as the probability. You then find the probability that x is greater than or equal to or less than or equal to the value that has been observed in the question, and you are going more extreme. So what I mean by that is if they've observed that you would expect there to be 5 something happens, and in the question they've observed 7 of them happening, you would find the probability that x is greater than or equal to 7. So you're doing 7 or more. If the probability that you've just worked out is less than alpha, less than the significance level, then you reject H0, meaning that you think it's quite rare to have happened, and so we do think that the probability is different from what the question suggests. If the probability is greater than alpha, well, it's just saying that there's a chance that could have happened randomly anyway, so there is no evidence to reject H0. Note, you should also be familiar with critical regions, okay? So you need to be able to do some of these things finding critical regions as well. The actual significance level is the probability P that you would have worked out at this stage up here. We are now on to the very, very last bit. We've got the normal hypothesis testing of the sample mean. Now the sample mean, x bar, should be normally distributed with a mean mu, and this time the variance this variance is sigma squared over n, where n is the sample size. The null hypothesis will be that mu is equal to k, and when I say k, I mean it could be like k centimeters or k kilograms or k millimeters, etc. It's actually the mean that we're talking about here. The alternative hypothesis will be that the mean is actually greater than k, or that the mean is less than k, which is going to be your one-tailed tests. Or it might be just that the average is not equal to k, which is therefore going to be a two-tailed test. So you assume that H0 is true, i.e. you assume that the x bar is normally distributed with a mean of k and sigma squared over n for your variance that you've got here. Then a bit like the binomial one, you find the probability that x bar is greater than or less than the mean of the sample taken. And that will be, again, clear from the question. You go in the more extreme direction. If P is less than alpha, then as before, you reject H0. So if it's very rare that it's happened, you might think, hang on, I do actually think that the mean has changed. I think that the mean is either bigger than K or smaller than K, because there's evidence to suggest that. And if P is greater than alpha, there is no evidence to reject H0. And so that is everything that you need to memorize for statistics. Now, there's an awful lot of stuff there, but I think this, if you can get it into your head, it's going to help you be one of those students who gets the high marks and not one of those students who gets the low marks. If you liked the video, please do hit the like button and consider subscribing to my channel. Go and check out part 1 on Pure, part 2 on mechanics, and I've also got some for core Pure for further maths as well. All of these videos are for Edexcel. They should really, really help you for preparations for your mock exams and for the real exams as well. Go and subscribe, check out my Instagram page at Bison Maths as well, and good luck.